Welcome to week 3, module 11 of Database Management Systems course in IIT Madras online BSc program. In the last week, over all the 5 modules, we have done a detailed introduction to the fundamentals of relational database models, attributes, types, the basic mathematical structure. We will have to do deeper later on. Then talking about schema, instance, different types of keys, and the basic operations like select, project, join, these kind of basic operations of relational algebra, and introduced the basic structure of queries, both in terms of the data definition language as well as for the data manipulation language. And using several features of the SQL language, select from where, and then different extensional features on that, we have shown how to form different types of queries, relatively simple ones I would say, and we have also shown the use of different set operations, use of null values, aggregation functions, and so on. So, it has been quite an active week last week talking about relational database model and SQL. So, we start this week today by doing a quick recap of what we have done. This recap is not in terms of restating what we have learnt last week, but it's trying to solve an example each for most of the major features that we have discussed, because it is very important for you now to actually start practicing coding in SQL, because it is, as you have seen, it is a kind of a programming language, but it is a different style of programming language, very different from all that you have done so far, which has significantly been procedural in nature. But this is the first declarative language you are doing, and based on a very different kind of model. So, unless you practice a lot, you will not be able to internalize the mechanisms to extract queries, making changes to the database structure or to the manipulation of tuples and so on, and going forward it will become very difficult. So, we would be doing a quick roundup of some key examples here. We will continue to use the same database schema of the university database that we had used last week. So, you could anytime refer to that. So, the first is the basic select, that is, you are given a relation and you have to find out information from that. So, from the classroom relation, we want to find the names of buildings in which individual classroom has to be taken out, which has a capacity less than 100. So, because it is classroom relation, you immediately know the from part of the query. So, from clause will be from classroom. That says that we are talking about, we will be dealing with the classroom relation. Then we are saying that individual classroom capacity must be less than 100. So, in the relation there are 3 attributes: room number, capacity, and building. Obviously, it goes without saying, though we have not looked at the schema. We can very easily understand by common sense that room number is the key here, because certainly there will be multiple classrooms in a building and 2 or more classrooms can always have the same capacity. So, it is a capacity which is bounded by 100. So, in the where clause condition, which is the predicate, we set capacity is less than 100. So, that tells us that we will get classrooms only where the capacity is less than 100. And then finally, we put the select clause, which says that what do you want? You want names of the buildings, right? So, we want the name of the building. So, it says select building. And as you have learnt that select from where this by default gives you a multiset. So, duplicates are not removed. So, here we specifically want remove duplicates. So, we are specifying the distinct qualifier. So, select distinct building. I will remove these markings now. So, select distinct building from classroom where capacity is less than 100. So, it goes to the table, looks at capacity less than 100, this will not qualify, this will qualify, this will qualify, this will qualify, this will qualify. Right. So, this condition is satisfied. So, in terms of in terms of buildings, this is what we will get. Painter, Tailor, Watson, Watson. Naturally, we want to remove duplicate, you are using distinct. So, one of the Watsons have to go, and this is what is your output. So, output is a table having only one column, that is corresponding to building, and it has 3 rows. Right. So, this is the commonest, simplest kind of select from where that you can have, and this by itself covers a huge part of the types of queries that you write. Naturally, if we look at, if we want that we would not remove duplicate, this query is same as before, except that, except that it is saying without removing duplicate. So, when you do not want to remove duplicates, naturally you do not say distinct, you can say all. So, which will mean that again these 4 are selected by the where clause. This is my relation taking a projection on building, because I want select building, and the Watson repeated will not be removed in this case. So, you have 2 instances of the Watson. Now, it may be noted that again I am saying it repeatedly so that it gets into your mind that select from where gives you a multiset. So, even if you do not say all, by default it will give you this result. So, giving all is just kind of explicitly saying okay, give me everything, but it is optional. If you do not give anything, then it will give you the multiset, it will give you the repetitions, it will not remove the repetition. For repetitions to be removed, you need to put the distinct. Right. So, this was the simplest of queries that you could have, and you can keep tracking on the left as to where we are progressing. Next, what we should say is a Cartesian product. Cartesian product is a, so select from where actually covers both your projection as well as selection, these 2 operators of the relational algebra. Now, Cartesian product is where you have 2 or more relations. So, let us look at, we are having 2 relations, student and department, and we want to take a Cartesian product, that is make all combination of tuples between student and department. So, if we did not write this where part, if we just did select name budget from student department, it will give you all combinations of students and department. But we have qualified that by saying that the student dot department is equal to department dot department, rather student dot department name is equal to department dot department name. So, what it will retain? Only those tuples, only those rows where the department name under the from the student relation and the department name from the department relation are same, designating that this student actually studies in this department, right. So, that is that. So, it is a Cartesian product with a qualifier, which we will soon see is what will turn out to be, we can do this very directly by using something called join, which we will introduce in the later module. And further we are saying that we have said that list of students of all departments. So, this is what comes here, and we want a budget which is less than 0.1 million, which is $100,000. So, the budget is less than, so it will have to match and the budget will have to be less. So, if you check back on the 2 relations that we have already given, in the example, then you will see that these are the tuples which will survive through it, where we finally show the name of the student. We are not showing by projection, we are not showing the name of the department, we are showing the name of the student as required and the budget as required, where the budget has to be more than your 10,000 or whatever, less than $10,000 in every case. You can check that is the case. Right? So, this is the little bit extended query, where instead of using one relation, now we are using two relations. Now, let us go further. Another way to write this relation is using the renaming feature, that is the as. We can any attribute or any relation I can rename with to a different name. So, first if you look at the relations, the student I have renamed as S, department as I have renamed as D, and writing this as is optional also. You can just write student S comma department D, it will mean the same thing, but writing as I prefer to be not smart but explicit, that way chances of error gets less. So, now I write S dot depth name equal to D dot depth name. We do not need to write student or department, that makes it a little bit less of typing. And also on the select clause, we are saying that S dot name, which is actually student dot name because of this alias, is given a new, this attribute is given a new name, student name, budget is given a new name, depth budget. You can see that I could have written this as D dot budget also, right, because D is the department and department has the budget. But I am not writing that, that is, I mean I can write, there is nothing wrong, but I do not need to write it because the budget attribute occurs only in the department. It does not occur in the student, so I do not need to distinguish, whereas the department name occurs in both. So, I need to distinguish which department name, it is the department name of the student or is it the department name of the department table that I am talking of, right. So, these are the variabilities. So, instead of budget here, I could have written D dot budget as well. Right? So, this is just another way of writing that query. When it gets more and more complex, you will probably, or when you want to do a self cross product between a relation and itself, you will certainly need to use rename, as you have seen already in the earlier discussion. Certainly in the where clause, you have a predicate. So, the predicate can use any operator of the Boolean algebra and or not. So, we are trying to see that we want to find names of all instructors whose department is finance or whose department is in Watson or Taylor. Right? So, we want names of all instructors. So, instructor table will have to be there, instructor table will be required. We want that the name or the department's building should be either Watson or Taylor, and that will satisfy. So, the department table is also required. So, this is how you decide that in the on the from clause you have two relations, instructor and department. Now, what is the condition that you need? You need to know the department of a faculty, right? Department of an instructor, because whose department? Whose department? So, you need to make sure that the department of the faculty of the instructor and the department name in the department has to be equal. Exactly the similar thing we are doing for students there. So, first part of the where clause has D dot depth name is equal to I dot depth name after renaming. Then we say that what are the condition on which we choose? This is the base condition. This will make sure that the instructor and department are properly correlated. That is, in other words, the join is happening. And then what you have, you say that either the department of the instructor is finance. So, I dot depth name is equal to finance, or building should be Watson or Taylor. So, we are using the in clause here by doing in Watson or Taylor. So, it means that if the value of building is Watson or the value of building is Taylor, this will be true, this predicate will be true. If it is something other than that, this predicate will be false. Mind you, this using this in, we are making it simpler, because otherwise I would have to again do or building equal to Watson or building equal to Taylor, lot more of verbosity as well as chances of error. So, what if you just carefully look at how it is composed, you can see that this join condition has to happen irrespective of anything else, that is the validity of the query, and rest of it is the total condition. So, you have a and look at this parenthesis, which makes sure that this joining condition will have to be true as well as this condition has to be true for the tuple to be selected, right. So, that is how you have and here, but within the selection criteria of the tuple, you have either the instructor is from finance or his or her building is Watson or Taylor. So, you have a or in between them, right. If you do not put this parenthesis, it will be wrong, because this will become and or and something, you will have to then figure out which order they should be evaluated and so on. So, when you have multiple such connectives and or qualifiers as not, it is better to put the correct set of parentheses according to the semantics. So, that is how this can be done. Other we showed is the use of string, which can be used to match a variety of types of values. Here we have the table of courses, and what we are trying to show is how to pick up find the titles of all courses whose course ID has 3 alphabets indicating the departments. You can see some have 3, some have 2, right, and then there is a hyphen and then the number. So, how do I say that there has to be 3 alphabets? So, I want 3 characters to come before the hyphen. So, I put 3 dashes, underscores, and then the hyphen, and then anything else is allowed. So, I put a while string percentage, which will match everything. So, this will get matched, this will get matched, this will get matched, but this will not get matched, because CS has 2 characters followed by a hyphen, right. So, in this way, if you check these whole of CS, EE, MU, these will get excluded, and whatever remains, then I am doing a projection on title. So, I will get the titles of those courses, right. So, this is how, and variety of ways you can use strings, and it is very powerful in this way. I think this was easy, that how do you order your output, all that I am trying to show here. Order by, basically we will say whatever attribute you have given, the result tuples will be ordered by that. By default it is ascending, but if you want, you can put ASC, it is optional, but if you want descending, you will have to put descending. What I am showing here is ordering by 2 tuples. So, what did I do is department name ASC, that is, it is to be within alphabetic order of departments, and within each department decreasing order of total credits. So, then total credit decreasing. So, if you see in computer science, first of all you have biology, computer science, this is the lexicographical order, and in computer science you have a decreasing order of total credits to be compiled here together, right. So, it is within computer science, this is, if I change this order, if I put this first and this next, then it will first get sorted by this total credit, and within equal value of total credit, it will get sorted by the name of the department. So, this in order by, it is very important to know, to decide which is the ordering that you actually want of the attributes. In is we have already discussed. So, the purpose of in is, I think, clear. So, I will skip this, you just check it out at home. In set we have three operations: union, intersection and difference, which is except here. So we say for the what we are trying to find out is we want to find the solution using union. So we say this is the courses that are offered in 2018. So semester is fall, this is courses offered in spring, and then you take them together, then you get the total set of courses. And please recollect that union is a pure set operation, it is not a multi-set operation unlike select. So it will remove all duplicates. If you want the duplicates to be retained, that is some courses which are offered in both should come twice, then you will have to write union all. Right? Similarly, you have intersect here, where you say the names of all instructors who taught either in computer science department or in finance department, right, and whose salary is this. Right? So you have first this either or, you put it in terms of in, so that any of the values will be fine. Get the instructors, get all instructors whose salary is less than 80,000. So it is kind of an AND condition that is happening here. So you subtract, you do the intersection, that is those who are common, that is who are in computer science or finance and has a salary less than 80,000 will come in the intersection, and that is the result that you will see if you check with the table. I will naturally urge you to check with all the results that we have given here. Similarly, you are saying find names of all instructors who taught either in computer science or in finance, this part remains same, and whose salary is either less than 90,000, greater than 90,000 or less than 70,000. Right? So what we are doing here is we are showing this by except. So we have except, so we get all the faculty who qualify for the list, and then all the faculty who satisfy the salary criteria, we just take them out. Right? You could have obviously done it using a more complex where clause also, but possibly it is easier to understand it through the set theoretic operations if there is such a clear notion of two sets or more sets getting formed. Finally, aggregation is easy. So all that you will have to remember that for aggregation we will need to group by on the entity on whose property we will aggregate. Here that entity is building from the classroom. Find the names and average capacity of each building. Average capacity of each building. This is what I want. So classrooms comes clearly. You want to find the name and average. So this comes clearly. Since I want it for each building, you will group by building. So together take on the building and take the capacity, and we are again done some qualifier. This is just not grouping, but we will consider only those capacity, only those whose average capacity is greater than 25. Right? So you take the buildings, compute the average. If that average is greater than 25, then only this becomes true, and then it comes in the output. Otherwise, it does not come in the output. Right? So this is how in this case, as it turns out, you will not have painter in the output. Right? Clearly, because painter is just one instance, so its average is that instance itself, which is 10, which is not greater than 25. So painted is not there in the output. Similarly, you can do minimum, which is very similar, doing the minimum, finding the minimum salary. You can do maximum, finding the maximum credit. Just work this out with the given table instance and convince yourself that they work properly. And finally, you have count, which counts the number of instances, number of rows basically. So what you are saying that from the section relation, so this is the section relation given in the figure. Find the number of courses run in each building. Right? It is run in each building from the section relation. So, from section. Run in each building. Each building means I have to group by the building. And then what do I want to find out? I want to find out how many courses are run. Right? So, I want to count. I will count by course ID naturally. The building is grouped. So, it is grouped according to building, like say Taylor here, Taylor here. So, these are grouped together, and then I will count the number of courses that will be there. Right? So, there are as you can see, there are 5 such courses will come. So, your count ID is 5. Right? So, I am counting based on, and then you can see that there are duplications of course IDs and they will be counted as distinct, right? Because naturally I am just counting the available number of rows in this. Sum is what you use to find out the total. So, for example, here we are finding out the total credit offered by each department. So, it is from the course table. So, from course offered by each department. So, group by is department, and what we are finding the sum of is total credit. So, we sum on the credit to get that. So, if we have say if I consider say music, I will get 3, only 1 entry. If I consider biology, there are 3 entries, 4 plus 4 plus 3. So, this will be 11. Biology is 11. Right? Now, this are occurring in an haphazard order. If I want, I can again put an order by on this, on the department name, and get it in the order of biology, computer science, like that. Those are all different choices. Right? So, this was just a quick roundup of the most common and most widely used. This is kind of the foundational part of the SQL language and its use. And I would again reiterate and urge you that you practice a lot of examples. There will be tutorials on this, there will be practice problems also given to you. But get confident on this, and as we move forward through this week, you will get to see lot more of SQL features which are more advanced and by which you can do more interesting things. So, thank you very much for your attention, and let us meet and discuss more of SQL in the next module.